Hello, my name is Maria from mathmammoth.com. In this video, we're going to look at linear versus nonlinear functions. And we've already studied linear functions quite a bit. Let's review now the basic properties, basic features of linear functions. For a linear function, its rate of change is constant, okay? Does not vary. And the input and output values as ordered pairs form a line when you plot them in the coordinate grid. That makes it easy to spot linear versus nonlinear functions. You just look at the graph. Is it a line or not? And then the equation. Any linear function, the equation will always be of the form y equals mx plus b, where m is the rate of change and b is the initial value. Now, it's true that the equation for a linear function could look a little different from that, but you can rearrange it to that form in any case. All right, is this a linear function? Think about it. We have a table of values, we don't have a graph, and we don't have an equation. So we're going to look at this first point. Is its rate of change constant? Okay, when x changes by 1, then does the y always change at the same rate? The y changes, okay, it goes down 8, minus 8 here. Also here, goes down or decreases by 8, decreases by 8, increases by 4, suddenly increases by 4, increases by 4. So no, this is not a linear function. It is linear for a portion of it, because at first the y values decrease constantly by the same number, by 8. And then the y values switch to increasing by 4. So this portion here also is a linear function, but overall it is not. Its graph would be something where it would be decreasing, then suddenly start increasing. But at a lesser rate. The rate of change here is not as much or not as steep as when it was decreasing. Technically, it would just be points, actually. We are only given points. But anyway, you get the idea. Now here is an equation. Does it define a linear function? Does it look like the equation y equals mx plus b? It kind of looks like it. But is it exactly like that? It is the 2 divided by x. It's not actually mx or 2 times x. So just by looking at the equation, maybe it's not linear. But let's make sure and calculate some points and see how they go here in the coordinate grid. Do they form a line? When x is 1, then we get y equals 2 over 1 plus 3, so that's 5. 1 and 5. When x is 2, we get y equals 2 over 2 plus 3, which is 1 plus 3 equals 4. Okay, so it could be a line like that, right? When x equals 3, we get y equals 2 over 3 plus 3, which is 3 and 2/3. Yeah, not the line. When x equals 5, then we get 2/5 plus 3. 3 and 2/5, just a little bit less than half. And then when x is 1/2, 2 over 1/2. Okay, 1/2 goes into 2 4 times, so this is 7. Like that. So not a linear function. Its graph actually would be like this. And it approaches 3, but it never actually crosses 3. Does this plus 3. It can never be less than 3 as x gets bigger. But approximately like that. Lastly, does this equation define a linear function? C equals 1.98 times w. Is it of the form y equals mx plus b? Well, yes. C equals 1.98 times w, so the m is here 1.98. And b is just 0. Y is our dependent variable, is c, and the independent variable x is w. So yes, it is of that form. Yes, it is a linear function. It is actually even describing a proportional relationship here, but definitely a linear function. All right, we're all done with this one. Hope it was helpful.